On my question. So this is on the day 2. It is September 23rd.
Did we get any paper yesterday?
We did yesterday.
Yeah.
Okay, that's all right. What's that lesson?
Yeah.
We're talking about it. That's okay.
You took care of that today, right? I will tomorrow. Okay.
Every time I look at that piece, it's supposed to make me laugh, I laugh.
Isn't that fun? The other one I laughed at, the one that's got all the verbs on it. And statue, pigeon and the statue, that's actually happened.
I've been posted on my bird, you know, that's a good look.
I don't think it's good about it.
It's like an old left tip, it's left to get pooped on by a bird.
I'm excited on the top of my head, down my ear.
Ooh, mine's on my shoulders, and then my head, I'm busy today. Simply, your I will, more important you,
How you doing? Are you working at it? Have no clue how to finish? Where are ya?
Oh, I just.
I have no idea how to use it.
What's that?
Where's them?
Are you all at least to a point where you're saying, I don't know what to do next?
Yeah.
Yeah, we will, but I don't want to interrupt somebody that's working at it. I don't want to interrupt you in the middle of it. And I don't know if this works out nice. It might work out to a fraction or a decimal, you know. Nothing says that it's only right if you get a nice integer little answer. So you don't like the fractions, right? And so you see fractions, I see dividers. Here's the divide by 5. Here's the divide by 15. Well, the way you undo dividers is with multipliers. So we want to multiply by something big enough to get the job done,
15.
which is a 15. And that's why that I, just so we wouldn't have to rewrite it, notice all the gaps in between. I'm going to go next to everything, and I'm going to say that I'm going to multiply by 15. Everything. Because it's not fair if you don't, right? It's an equation. Whatever you do to one side, you got to do to the other. And you have to do it to the entire side. So everything gets multiplied by 15. Remember Mr. Stoddard talked about where you write that 15 is a big deal. Make sure that 15 is not down here next to the 5. Make sure it looks like a multiplier by 15. Now, some of you would rather do this. Some of you would rather see this as 15 times 3 is 45, divided by 1 times 5 is 5. Some of you would see this as 45 divided by 5, which is 9 times the x. Not the way I do that. It's too hard. I'd rather make it easier. I see it as, it's just all fractions, and both of these can be divided by 5. 5 into here goes once, 5 in here goes 3 times, see, my numbers are smaller, and then I see 3 times x is 9x, plus 15 times 2, 30, and here we go again. Some of you see 15 times 3 is 45, 45 divided by 15, I don't want to do that, that's too hard. What I see is, I can divide each of these by 15, or, so divide them both by 15, or divide by 15, we'll undo multiply by 15, so that's just 3, plus 15 times 3 is 45x. 15 times 3x, I should say. Now, let's, remember all those little tabs, that if you go find the place that you've got the most x's maybe, which is over here, 45 is more than 9, and we'll subtract 9 x's from both sides. So here's 30, and over here would be 3 plus 36 x's. Get rid of these, so subtract 3 from both sides. That makes 27. Over here, 36 x's. Divide by the 36. X is, I'll come over here and write, x is 27 over 36. If you want to turn that to a decimal, that's okay. Divide it out, 0.75, or you can divide these each by 9. Divide that by 9 is 3. Divide by that 9 is 4x is 3/4. Is that what you got? I thought you had a fraction. I thought so. You can work it with the fractions, but who would want to do that? Like you could subtract 3/5 of an x from both sides or something, but somebody wants to do that. Okay. That's enough of that then, I think, for a while. Let's get those graphing calculators back up. Pick up where we left off yesterday. You don't have one? Come bring me your phone, and I'll trade you for today. If you do not have a graphing calculator, come see me. I'm not coming to you, come see me with your phone. Great. So let's go ahead and fire that up. Go ahead. Turn it on. Got to graph some lines and some other things eventually. We'll see how far we get. Y equals, whatever you have, clear it out. I don't know if you still have stuff in there from yesterday. I think this might be some of our stuff from class. And let's go graph, for starters, negative 3x plus 2. And we know what we're going to see. It's going to have a y-intercept at 2. And then it's going to go down 3 and over 1. Down 3 over 1. Just make sure you remember how to do that much from yesterday. Remember the negative down on the bottom. You can't use the subtract. That's not a negative. Just down on the bottom. Negative. We say 3x plus 2. 3. Remember where x is? It's up here. Is x plus 2. Oh, I put clear. Gosh darn it. Negative 3x plus 2. Graph. Remember the graph button up there? No surprises, huh? Okay. Next one. Let's just completely clear that out. And, how far is this over here?
10. Negative 10.
Negative 10. Over here?
10.
10. How about right here?
Negative 10.
And way up there that I can't reach?
10.
Okay. Subtract this equation. Negative 2/3 x
How do you do the
plus 31.
fraction again?
That's where you'll go parentheses, negative 2 divided by 3, parentheses, x plus 31. And you can do that on any calculator that doesn't have a fraction button. Just do it as divide. So negative 2x, or negative 2/3 x plus 31.
Get a graph. Neither did mine.
Mine's on graph.
We say plus 31, is it? So, is that what you typed? Are you sure you typed it in okay?
Yep.
Well,
Yeah.
let's go push graph. And you're all thinking, there's something wrong with this. Cheap thing. $100, won't even graph. Stupid thing. Yes, it did. Where's the y-intercept at? Where's your y-intercept? 31. Alright, so here's your negative 10 to 10. You know where 31's at? Well, right about there. And then we're going to go down 2 over 3. You graphed your line. Just your window's not big enough to see it. So let's change our window in case that happens to you. How high up do you think? So this is just 31. If I chop it off to here, you're going to see this. So how high might you want to go? That's just a judgment call. You can try 100. You can experiment a little bit, but more higher than 31. So here's where you do that. Go to the button that says window. Clever, isn't it? Touch that button on the top that says window. Now, which one do we want to change? If I want my graph to go higher, Y max, absolutely. So go just change it to anything and see what you see. Y max, I think I am going to go with 100. And then just go push graph again.
Holy cow.
There it is. Now, if you're going, so we went from negative 10 to 100. So those little intervals, they're awfully tiny, going like that. It is still counting. The scale of it's all whopper-jawed. These are still worth 1 because we went from negative 10 to 10. But there's 0 to 100 up there. Like a 1 is only about to here. And then 2, 3, 4. Because right there's 31. So this is about 10, 20, 31. Our size is all distorted. It's like somebody's really stretched it this way. But that's okay. So that's what, when you can't see something, it's probably just because it graphs it outside the window that you're looking at. Let's take our window back to normal though, just for some other things we're getting ready to do. So go back to window, and let's go change it back to, well, I'm going to change it to 50. I want to know what 50 looks like first. That same graph, if I only would have went up to 50. That looks a whole lot different, doesn't it? And you can make this window be anything that you want. Here's a mistake that a lot of people make. Can I show you something on the window? Some people will do, see how that says negative 10 up there to 10? Some people will make that go 10 and leave that 10. So you're saying start at 10 and end at 10. I'll probably get some error message. Let me see what that says. Yeah, see window range. Because it doesn't make sense to have your window start at 10 and end at 10. So let me go back and...
Does the theta x have anything to do with it?
Just the what?
On the colored version, he's getting an error message, and his values are correct. They appear to be correct.
So negative 10 to 10, negative 10, and this down here. See where it says this? Yep, you're right. That delta x.
Sorry, delta.
It is saying that the intervals as you count. Like, let me go point up here to my screen. Delta F means how far apart are these? What's the change going from here to here? And up here, this is worth 1. This is what it's counting by 1s, and this is counting by 1. Yours says like 0.07, so it's trying to count by some little tiny something. Let's change that to 1 and I bet we'll be okay. Oh no, that was the scale. Never mind, I thought that was the scale that it was counting on. I don't know what that is. I really don't know.
Tomorrow, maybe.
I don't know what that is.
Yeah, one period.
So we were okay.
Third with Miss Fusion and Miss
Valid
Webber.
dimensions.
Okay. Third period.
Here, so this has got something to do with the step plot. We will learn that next week. We'll start to graph some things. I think we've got something turned on there. Let me go check a look to see. We need that to be turned off. You don't know what that means right now, so we're going to select it. Here, I'll do it. Watch what I'm going to do. I'm going to select it, and then I'm going to move over and tell it to be turned off. And now I bet we graph just fine. There it was. You had something called a scatter plot. And next week we'll be doing some stuff with that too. Out of that. So, did you follow it along? You didn't do anything we just did up here.
Yeah, I did.
That's what I typed in for negative 2/3 x plus 31. So, let me get you a paper and we're going to just graph away today. You're going to have calluses on the tips of your fingers when you're done. Oh wait, you already do because you text all day long.
Wait, how do you make fractions on these
Indices.
There's no ABC sign.
Indices.
For all parentheses?
Indices.
I don't know how to get out window.
What we just did up there. That's where I went over.
But I wanted to find out how to put all these in.
This will end up being a page in your book, but there's no reason to put it in there until we're done with it. So, you see question 1? Just by looking at them, what's different? Where it says, what's different about the graph of y equals 2x and y equals 2x squared? What do you see that's different? The square, right? So, let's just go see what's happening and follow along, really. Go to your y equals, type them in. Let's just go to y equals, clear that out.
I got the curvy graph.
Whenever I graph, I get that right there. This is a bar graph.
So, one of the things, here's y equals 2x, like that. Oh, I gotta teach you how to type in 2x squared. Okay, ready to learn that one? Tristan? Okay? To do 2x squared, you don't, that x squared button, you'll use it, but not like you think you would. I'm gonna tell it to do go 2. Now go type in x, just like you did before with the x, but then watch where I'm gonna point. Then come over here and tell your calculator that x that you just typed in, you want to square that. So then push that button and it will square it for you. And then you can go push graph, sure. So there's the line, and that's called a parabola. Okay? Now we're going to copy that down in just a minute, but I've got something else that I want to take care of first with some things. Is on your sheet, I want you to do this. Because I'm not going to let you use that calculator for anything this year that you don't know how to do here without it. There is not some little genius that lives inside of here. The little genius is inside of here. It might get the job done faster, but you're going to know that you can do it. You're just as smart as the little guy that lives in there. There's no little black magic or anything that happens. So, let's go back and do you see where, so for number 1, I guess the difference was, if you want an answer for question 1, the difference was whether the x was at x or at x squared. And then when it says set up an xy table for each, under y equals 2x, let's do that. Let's set up a table. And let's pick some negatives. And let's pick 0. And let's pick positive. But we want to make things easy. You know, there is no reason that I pick these. I'm just going to pick some negative, 0, and a positive. We don't need your calculator. Remember I said it's all up here. If I put a negative 3 in for x, what's 2 times negative 3? Negative 6. If I put a 0 in, what's my y? 0. If I put a 6 in there, what's y? 12. And then if you had to graph this without the calculator, or if you forgot everything all about slope, you would just go graph those points and it would be a nice happy little graph. So let's go to this one. Y equals 2x squared. Let's make a new XY chart.
-4.
We might pick a few more things. We can pick -4. Here, let's go -4, -2, 0, let's maybe get some symmetry up here, +2, and +4, just so we can kind of have a balanced, taking a look at that. And here we go, just your thinker. Let's go figure out what those are for each one of those. So if I put a -4 in right here,
Are you with us? So it'd be -4 times -4, which is positive 60.
and then times 2, yeah, woo, going way up there. Now let's go put a -2 in there. Put a -2 in there and square it, makes 4, and then times the 2, that's right, now you're up to 8. My favorite of all is 0, because you square it and multiply it by 2. 0. Now let's go put a +2 up in there, you gotta square it first. 4 times the 2 makes the 8. And then if we put our 4 back in there, 4 times itself, 16 times the 2, 32. So then underneath where it says sketch a graph, I don't have room to sketch a graph underneath, but underneath your 2x, just sketch. And I want you to get these points on there though, by using those points. And you can just be rough, so if I'm going -3, -6, 0, 0, 6, 2. Scale was off a little bit. Try to make yours look like a straight line. Goes through the origin, right? It's direct variation. And it goes up 2 over 1, up 2 over 1. Now let's go put a graph for the other one. Let's go graph this one. And we're going to go to -4. -4. 32. -4. You might do this sometimes. So I'll do this. I don't want to count all the way up to 32. I'm a little bit on the lazy side. I might do something like 10, 20, 30. So -4, 32. That's pretty good. So take -4, 32. And -2, 8 would be almost up to the 10. And 0, 0. And 2, 8. There's a little bit of symmetry. 3, 4, 32. And you already saw from your graphing calculator about what it's going to look like. So you could do it by hand, right? Convinced you could do this by hand? What was the hardest thing you had to do? 16 times 2 is 32, right? You can make an XY chart, pick all of them. I do got a little secret though to show you. Go back to your calculator, go back to the y equals for all that stuff. Where your graph button was, what's it say up above it? Table. Go do that. It's the second button. That's your XY table that you just made. So the first one are X and Y. There's the X's that go with the Y. Here, let me erase this. Actually, let me turn this off so it's not, you can see yours, you don't need to see mine. So, do you see X and Y1? See if you see these values on there. Do you see them? Do you see it? X of -3 where it says -6, and 0, 0, and then 6, arrow down. Take your arrow, go down to the 6 for an X. Do you see your Y? I got blank faces. Yes, are you okay or no? Not seeing it? So I got this XY chart where it was -3, -6. Well, I better start at the bottom. 6, 12, here's the 6, here's the 12, here's X, here's Y. When X was 0, there's Y. What else did we have? A -3. If I go up here, there it is. -3 was a, here I'll highlight it, watch the arrow. -6.
Right when you're charting it.
For the parabola chart, it might be easier to see these. Let's go find -432. -4, let's just go up. Whoop. There's -4, and way over there is the 32. That's off of the other one. Or 2, 8. Let's go down to +2. Can I get there? Yeah, there it is. See, there's +2, and there's 8. With two equations there, it might be harder for you to see. If you just have one equation, it's easier. Like if I go back to this back here and just clear out the second one, just to clear something out, and then go over to that table. It's only one equation, your XY table is easier to see. And we can practice that. Let's practice that more. Let's go down to the middle of the page to that statement. And it says both of those are direct variation because they both have that pattern of y equals k times x, or y equals k times x squared. They're multipliers, not dividers. But for the rest of the day, everything's going to be x squared. Y equals k times x squared. So this is where lots of your typing comes in. Is everybody looking at use your graphing calculator paragraph? Down at the very bottom, do you see use your graphing calculator to graph each of the following? Put all three equations on the same window. I'll do the first set with you. If you don't have a graphing calculator, it says you're going to have to do it by hand, make XY charts by hand, which we did, and we made it, but you all have a calculator that I think you'd rather do them that way. Make XY charts by hand. Alrighty, so do you see how we have a group? It says y equals x squared, y equals 5x squared, y equals 2x squared. Type all three of those in.
X squared.
Now go hit graph.
You broke my calculator.
You touched it first. Back when I was messing with you guys, that I said that 10 to 10 you get a message that needs to stay.
You were going?
There's one of them. There's the second one. And there's the third one. Now, it says to sketch each one of those and to label which is which. So it was probably happening so fast for you to sketch and keep track of that maybe we better just do them one at a time. So let's go put in place y equals x squared. So we go to the x, and then we go square it. And let's just graph that one. We'll graph them all on the same one, but let's just do them one at a time. So I'm going to say, this just says sketch, and I'm going to say that is y, that's my graph for y equals x squared. So get that on paper. Take a good look at it too, so you don't forget what it looks like. Now let's go back to y equals, and let's just jump down, and let's add the second one. That's 5x squared. 5x, tell it to square it. Now the other one's already going to be there, so just watch this one. When we get done, that old one, it didn't erase it, it's still going to be there. Go push graph. So there's the old one. And how's that different? Skinnier. So draw that in. And label it that that's y equals 5x squared. Now let's go do the third one. Let's go back y equals. And let's graph a third one down in there. That's a 2x squared. Now the other two will still be in place, so you're going to have to watch where this one fits in compared to the other one. Let's go hit graph. And it went down in between them, didn't it? Did you see it? So that went down in between. So that is the y equals 2x squared. Can you tell what the 2 and the 5 were doing to your graph? How was it changing them? What do you mean by smaller? Being more descriptive. Shorter? Not shorter? What do you mean by smaller? Show me with your hands. What do you mean by smaller? So they went narrower, didn't they? They got skinnier. What is skinnier, the 5 or the 2? Which one's skinnier, 5 or 2? The 5 was the skinniest. So watch for that as we do some more. Let's go to the next group for you. So go back to, start all over. So go back to y equals and clear them out because you're going to have a new group. And start out with, type the first one in, which is y equals x squared. And you're making a new graph. It'll be a new graph of 3. We'll go tell it to graph. And put that in place so you won't miss it when it's time to do the other one. And label it so you don't get them mixed up. So that's y equals x squared. Now let's go add the next one in. What's different about the next one? Do you see it? What's that second one got? A negative. So the negative down on the bottom. Don't use the subtract. Negative x squared. And then go push graph. Okay, that's easy. That one's easy to see. So now go add that. And label it. Y equals a negative x squared. Turned it upside down, huh? And now we'll go add that third one in. Back to y equals. Jump down to the third one. And we got y equals a negative. Got any predictions? Where you see it? The shape. What's my shape going to look like? Upside down and skinny. Yeah, it is. There it is. Upside down and skinny. So add it to your graph and label it. I'm going to turn this off because I don't like hearing it, and you're going to do that third group, just like we did this too. Isn't it cool? And then there's a second one, and there's now. Do you know which is which?
Mm-hmm.
So when you go to label it on your paper, yes. So, oh yeah, because yours colors.
Yeah.
Is this a rechargeable, or
Yep.
do you put batteries?
George.
Be careful with that. You know, when you go to charge it, like you got to charge it for like a day or two.
I charged it once.
Well, I know, but I mean when it needs charged,
Mm-hmm.
you got to charge it for a long time. Yeah, you got it.
Are you supposed to put text in parentheses?
Functions, I didn't practice any of them.
I didn't think you had to put it in parentheses.
You have to put those in parentheses?
No. Well, yes, as dividers. So when you go to do your fraction,
Yeah, put it Prince.
like what's that first fraction, like
1/2.
the 1/2, put the 1/2 as parenthesis, 1 divided by 2, parenthesis.
Hmm?
Got it? Pretty slick, huh? Pretty slick. That last part, when you've got those three, by the way, what's the name of that shape?
Parabola.
Parabola. Do not say parabola, you sound like a big dummy. Unless you're trying to on purpose, and sometimes I do, just to point that out, to be funny. But don't let anybody think that that's really what you're saying and meaning is parabola. And if so, if you do make that mistake, please don't tell them that we're your teachers. Say Mrs. Wanamaker's your math teacher. Parabola, parabola, parabola. Now, would you write 3 things down there? 3 conclusions? So, negative signs did something. Fractions did something. Those other multipliers did something. So 3 conclusions as to when do they get skinny, when do they get fat, when do they open up, when do they open down. You could probably list more than 3, but come up with 3 things that is true about that number out in front of your x squared. What's it doing? Glad you like the color, but this isn't complete. So have
This
this
is the
or
holder
this or
Friday.
this or- What's that?
This is the holder Friday, right?
Yeah.
I was
But
like-
you
I
could
was
do
just
that.
getting out of the way.
I like to take that in your sleep. How you gonna do this?
I'm usually get rid of that little bar graph over there.
We will, but it's lickety split, quick and easy. It will be. Let's share some of those 3 things. Adeline, what's one of your 3? Negatives open down. Negatives open down. Hunter.
Fractions make the parabola wider.
Fractions make it wider. The smaller the fraction, 1/10 makes it wider than 1/2. Yep. Fractions make it wider, and the positives go up. That's a good one. Positives, a positive. Do you know what you call that number out front? Whether it was a -5 or a 1/10, that number out to the left of your x squared, the number out to the left. It's called a coefficient. Do you know that word, coefficient? Do you know what that means, or is that a word worth knowing? Words worth knowing? Let's go to the words worth knowing. Words worth knowing. In your notebooks, go to words worth knowing. What was the last word worth knowing that we had?
Constant.
Constant. All right, this one is a lot of I's. Coefficient. Coefficient. Coefficient.
You just write 2x squared and insert 1
We could do that. Let's put an example there. That might be better than the big old worded definition. I think that's a good idea. Let's do something like that. For coefficient, let's go 2x squared and circle the 2. Or let's put another one. 1/10 x squared and circle the 1/10. That's a good idea. Coefficient. We don't have time to put that in your book, but we will tomorrow.
What are we putting in your book?
We'll put everything in your book tomorrow. Both of these will make it there.
Also,
It will, we'll just, so don't lose that sheet, that's pretty good sheet. You know enough about these parabolas that you don't need the calculator to run these through. You know enough about what they're going to look like, what makes them open up, what makes them open down. So if it says sketch, it can just be a sketch from up here, from what you think it's going to look like. And then we'll wrap that up tomorrow.
So what's it gonna look like? I don't know. I didn't do that. You didn't?